Hi everyone. So for my midterm topic, it's exponential functions. And so one example of an exponential function is 3 to the negative x minus 5. And so to find the y-intercept, x-intercept, and f of negative 2 and the horizontal asymptote, domain, and range, you can look at it and find it from a graph. So first you want to plug 3 to the negative x minus 5 into y1. And so that's what it comes up as. And then to find the y-intercept, you press second calc value and you put 0 in for x. And then you get y is equal to negative 4. So the y-intercept is 0, negative 4. And then to find the x-intercept, you want to press second calc 0. And then you want to move the cursor upwards, left, and down for right where the x intercept is. You press enter, and then you get negative 1.464 as your x-intercept. So it's negative 1.46 comma 0. So that would be right here. And then to find f of negative 2, all you want to do is plug negative 2 into the function. So it would be 3 to the negative 2, which is 3 squared minus 5, and that is 4. And then to find the horizontal asymptote, also, this coordinate is 2, negative 2, comma 4. And those are the points you want to have on the graph. And then so to find the horizontal asymptote, first we want to connect these points. Sorry, it's a little scribbly, but we end up finding out that the horizontal asymptote is y equals negative 5, because when you put a dotted line across, that's where the line is approaching. As you can also see right here on this graph, that it's also approaching negative 5. And so the domain for this function is x, such that x is all real numbers, because there's no limit. And then the range of this function is y, such that y is greater than negative 5. And this is because, like I said, the line is approaching negative 5, so everything has to be greater than negative 5. Okay, and then the next type of problem we're going to be doing is a decay problem. So I'm going to read the problem out to you. It says, at a certain prescription drug is eliminated from the body at a rate of 15% per hour. Presently, there is 12 mg of the drug in the body. And so the original exponential function is f of x equals a b to the x plus k. So the first part we need to find is, it says create an exponential model that will compute the amount of the drug remaining after T hours. So to find this, we just look at what is said in the original part of the problem. So it's eliminated, and it's at 15% per hour, and there's 12 mg of the drug. So the function would be f of x equals 12 to 0.85 to the t. And how we can find 0.85 is you subtract 15% because from 1 because it's eliminating, and it's decreasing, which means it's decaying. And so the next part of the problem is that it says how much of the drug will be in the body after 4 hours. So you want to plug 4 in for where T is because you're trying to find how much of the drug will be in the body after 4 hours. So it would be, the function would be set up like this: f of x equals 12 to 0.85 to the t, 0.85 to 4, and then that equals 6.264, which equals 6.3 mg of the drug. And then the third part of the problem is the drug needs to be taken again when the level falls below 5 mg. If this dose was taken at 10 a.m., when will the next dose occur? So it falls below 5 mg, so that means that we can put 5 as equal to 12 times 0.85 to the t. And then we want to put this into y1 of your calculator. And then we want to put this into y2, and then that into y1. And so when we do that, so it'd be 12 times 0.85 to the t, which would be x, and then 5. And then it might not show up right away, so we might need to, oh wait, maybe. So then we want to find that exact point. So we want to, where they intersect. So that would be second calc, and then intersect, and then press enter, and then you end up getting 5.386, and so that's how we find the answer to that, where the point of intersection is. But we want to find the time, so it started at 10 a.m. and then we want to add 5 hours to that, which would be 3 p.m. And then this number right here is equal to 23 minutes. So then that would be 3:23 p.m. And that would be the answer to the third part of the problem. And so lastly, another type of problem is the increasing amount, which is where there's a growth for an exponential function. And so this example is a company's sales revenues have been increasing at 13% per decade. Sales in 2005 were $755,000. So first we have to write a model again. So let's do increasing at 13% per decade, and then sales in 2005 were $755,000. So to write the model, we would do f of x, because it's a function. F of x equals 755,000 times 1.13 to the x. And so, like I said, since this is an increasing in growth kind of problem, we want to add 13% to 1. And so that's how we get 1.13. And then the second part of the problem is we need to predict the sales in 2030. So that would be f of x equals 755,000 times 1.13 times to the 2.5, because when we do 2005, so 2030 minus 2005, we get 25, but we need it per decade, so we make it 2.5. So then the answer to that would be 1,024,809.31. So that would be $1,024,809.31. And then the last part of the problem is, according to the model, in what year will sales be up to $1 million? So to find out, we do $1 million equals 755,000 times 1.13 to the x. So we equal that because we're trying to find what year will sales top that. So to solve this equation, we divide by 755,000 on both sides, and then we end up getting, when we put that in the calculator, 3,245 equals 1.13 to the x. And then when we put this in the calculator, let's re-put this in. So that'd be 1.3245, and then y2. This would be y1, and this would be y2. 1.13 to the x. And then we want to find the point of intersection for this. We might have to change the windows a little bit, but let's see. Second calc intersect, and then we end up getting 2.299, and then 1.3245. And we want to find the year. So 2005 plus 23 years is 2028. So year 2028 would be the answer to that. Thank you for listening to my screencast.